All right, so what if I told you that one of the biggest, most important ideas in all of programming is something you actually use every single day, and you probably don't even know it? Today, we're going to pull back the curtain on this powerful concept that sounds super complicated but is actually surprisingly simple. We're talking about encapsulation. Okay, just think about an old MP3 player for a sec, or, even the music app on your phone. You know exactly how to use it, right? You tap a button, a song plays. Super simple. But have you ever stopped to wonder what's actually going on inside? What's the magic that's turning a bunch of ones and zeros into your favorite song? And that right there is the key. On one side, you've got the interface. Just a couple of simple buttons. Play, pause, next. Easy. But on the other side, you've got the implementation. And that's this mind-boggling maze of circuit boards and lasers and code that makes it all happen. The whole point is, as a user, you only ever have to deal with the simple part. All that crazy complexity, it's hidden away, and that's completely on purpose. So, this idea, this separation between these simple controls on the outside and all the complicated stuff on the inside, that's not just a good way to design a gadget. Nope, it is a fundamental, core principle of modern programming. So let's make that jump from MP3 players to actual code. And here it is. This is encapsulation. It's basically the programming version of our MP3 player. It's this core practice of bundling up all the related stuff, the data itself, like the song file, and the things you can do with that data, like play or pause, and wrapping it all up together in a single, neat little package called an object. So what exactly gets shoved into this bundle? Well, two main things. First, you've got the data itself. In programming, we call the stuff properties. For our song, this would be the raw information, right? The artist's name, the song title, the actual audio file. Then you have the actions, the things you can do with that data. We call these methods. These are the verbs like play, pause, or skip. See? The data and the actions that work on it, all together. But just, bundling things together isn't the whole story. Not even close. The real power, the secret sauce of encapsulation, comes from a related idea called information hiding. This is where our whole MP3 player analogy really starts to shine. And here's the golden rule. When one part of your code wants to use another part, say to play a song, it doesn't need to know all the messy details of how that song gets played. It doesn't care how the audio is decoded or what signals are sent to the speakers. All it needs to know is that there's a button, a method called play. It just trusts the object's public interface to get the job done. Now think about why this is so incredibly powerful. Let's say some brilliant engineers invent a brand new, super efficient way to decode music. They can rip out all the old guts of the MP3 player and replace them with this new technology. But here's the thing. As long as that play button on the outside still does what it's supposed to do, you, the user, don't know and you don't care. It's exactly the same with code. We can totally refactor or fix the internal logic of an object, and as long as the public interface stays the same, we won't break all the other parts of the program that depend on it. It's a game changer. Okay, so this whole hiding thing, it's not just a friendly suggestion. It's not just programmers pinky swearing to not touch each other's code. No, this is a hard rule, and it's often enforced by the programming language itself, using something called access levels. First up, you've got public access. This is easy. Just think of the buttons on the outside of the MP3 player. They're meant for everyone to see and use. This is the official, public-facing interface for your code. And then, on the flip side, you have private access. This is the internal wiring, the circuitry inside the box. These are all the little helper functions and bits of data that the object needs to do its job, but that nobody, and I mean nobody, from the outside should ever be messing with directly. This is the hidden stuff, the implementation. So the breakdown is really simple when you look at it this way. Public, that's for anyone to use. It's the buttons on the outside. Private, that's only for the object itself. It's the circuits on the inside. And creating this barrier is absolutely crucial. It stops other parts of your code from accidentally reaching in and, scrambling the object's internal state. Trust me, that's how you get some really weird, unpredictable bugs. Now, here's a quick real-world note. Not every programming language handles this in exactly the same way. Take a super popular language like JavaScript, for instance. By default, pretty much everything is public. But clever programmers being clever programmers, they figured out all these established patterns and tricks to create privacy anyway, so they can still get all the awesome benefits of hiding their information. All right, so you might be thinking, this sounds like a lot of work. Why bother? What is the actual real-world payoff for doing all of this? Well, it turns out the benefits of building software this way are huge, absolutely huge. Let's just run through the big ones. First, security. You're protecting your data from being changed by accident. Second, simplicity. You're hiding all the messy complexity from the person using your code. Third, maintainability. This is a big one. You can fix or upgrade the guts of an object without causing a chain reaction that breaks your entire application. And finally, organization. It just keeps related data and actions neatly bundled together where they belong. It's all about writing code that's cleaner, safer, and way easier to work with in the long run. So let me just leave you with this one last picture. Imagine trying to drive your car, but there's no hood. The entire engine, all the hot, spinning, greasy, complicated parts, is sitting right there in the passenger seat next to you. It would be an absolute nightmare, right? Dangerous, distracting, a total mess. Well, encapsulation, that's the hood for your code. It safely covers up all that insane complexity so you can just focus on the simple interface, the steering wheel, the gas, the brake, and that is the secret. That's what allows us to build the massive, complex software that runs our world and keeps it from falling into total chaos.